Problem number 1. First thing you need to remember is the degrees have got to be the same in order to add or do anything with any of these terms. Okay, so I've got in problem number 21, and I will attach this worksheet, these degrees are the same, so we can work with them. If they were different, we would have to either get them the same first, and then we could work with them. We got a problem down, we'll take a look at 22, they're the same. 23, they're the same. 24, we've got a negative pi over 5. That's not the same as pi over 5. So we have to do something with that first before we can work with those. Same with 25. We've got the sine of 70 degrees and a cosine of negative 430. Those are not the same, and we can't just add or subtract them. We're going to have to use even and odd properties or coterminal angles to make sure we have all the angles values the same first, okay? But in problem number 21, they are the same. And we know, using the first Pythagorean identity, sine squared plus cosine squared equals 1. That just equals 1. So, 1. Done.
Is that the same with all of them? If it's like cosine and sine and they're the same number, it's just always 1?
What do you mean all of them?
If it was like cosine of 80 plus sine of 80, would it always be 1?
Yes, because the formula is the sine squared of theta, some angle, plus the cosine squared of theta, the same angle, whatever that angle is, they're just calling it theta. If those are the same, then yes, then it's equal to 1. So the next one, we're going to use the second Pythagorean identity, which is 1 plus tangent squared equals secant squared. Let me go ahead and just write that. 1 plus tangent, that's terrible. Tangent squared of theta equals secant squared. Because what we're going to do here, in problem 22, this says secant squared minus tangent squared. It's really similar to this identity. If I can manipulate this identity somehow and put it in this format, if I could subtract the tangent squared from both sides, just using our algebra skills, I'm going to get the secant squared of theta minus the tangent squared of theta equals 1. So we've got the secant squared of theta, in this case theta is 18, minus the tangent squared of 18 degrees, again. What's that going to equal?
0.
Should I rewrite what I wrote up here? Once you subtract tangent squared from both sides, and basically remember from algebra 1, there's a line going down the center here, there's your equal sign. I've canceled that, so the only thing that's left on this side of the equal sign is the 1. And on the right is secant squared minus tangent squared. So the secant squared of theta minus the tangent squared of theta equals 1. So what is the secant squared of 18 degrees minus the tangent squared of 18 degrees equal to?
1.
That's it. Yeah. What's the reciprocal of cosecant? So we have to know the reciprocal of sine and cosine. The reciprocal of sine is what? The reciprocal of cosine is what? The reciprocal here is cosecant, and the other one is secant. One way to remember that is notice sine starts with an S, cosecant starts with a C. Cosine starts with a C, secant starts with an S. They're opposite. They're reciprocals. So the cosecant, this is actually equal to 1 over the sine. Really? Really, Cheryl? There we go. So it's the reciprocal. So I'm going to rewrite this one here. I'm just going to erase all this. There we go. And notice they're the same, we've got the same theta here, so we are good to go. Well, looky there. What's that going to be? always equal to 1, by the way. We did have 3 problems that equal 1. But they don't always equal 1. Okay. Please let the next one not be 1. Okay, the next one's not 1. Awesome. That's equal to 1. We're going to do one more. Okay, so last time you learned about even and odd properties. The cosine function is what? Even or odd? I wish I could show you. Okay, well, I know you can't see it in the video here, but a while ago I drew on the board the even and odd graphs. So if you think of cosine is x, right? I'm just looking at pi over 6, okay? If I look at pi over 6 and 11 pi over 6, or you can think of that as negative pi over 6. Let's think of it as negative pi over 6. The x distance is still positive. It's the same for both of those. So the cosine is going to be the cosine is going to be the only function that's going to be even, as well as its reciprocal. All the other ones are going to be odd. So we can rewrite this negative pi over 5 as cosine of pi over 5, because it's going to be the same x value. Does everybody understand? The same, I just used pi over 6, but the cosine is the x distance, and for pi over 6 and negative pi over 6, the cosine of those two angles are still a positive, the same value. So I'm going to rewrite this. I wish I didn't have to erase all that. I got to figure out a better way to do that. I'm going to rewrite the cotangent as, we know the tangent is sine over cosine. I'm going to rewrite that as cosine over sine. So all I've done so far is just rewrite at the pi. All I've done is rewrite cotangent as cosine over sine. And now I'm going to rewrite cosine of negative pi over 5 as pi over 5, because they have the same values. And the reason I'm doing that is because I need all my angles to be the same. Because now I can actually add, subtract, do what I need to do with these values and simplify these expressions, because all of the angles are the same. They're all pi over 5. So what is that?
0.
Yay, a different answer. Okay. You guys went over even and odd properties last time, right? Or do I need to make a separate video on that? I know there's just so much information. All right, we're gonna go ahead and stop. We will do the last problem though.